Fine. So let us start. So today I've brought some code for you. I would hope that you have all the access to your this Python standard library, and then you can also download some of these specialized software which are available free of cost, and they are NumPy and Scikit-learn, Pandas, Matplotlib. And if you want all the packages together, I think you can also use Anaconda website where when you will download everything, everything is freely available and bundled with the same package. So Anaconda Navigator appears like this, in which you can click at Spider. So Spider provides you the Python code development environment. So from there you can start. There are example datasets available at this website, which is known as UCI Machine Learning Repository. So it is University of California, Irvine, which is maintaining the standard datasets. So the frequently used dataset by beginners in machine learning is Iris dataset. It is a very simple three-class classification dataset. It is about classifying a particular flower known as iris into one of these three classes: Iris versicolor, Iris setosa, and Iris virginica. On the basis of these four attributes, sepal length, sepal width, petal length, and petal width. So four such information is obtained through different pre-processing mechanisms or through hand-fed data. Maybe they took some 150 flowers and then measured each of them to identify their attribute values. So then you have to see how best you can classify the unknown data into one of the classes. So you will see that these data samples for setosa class, they represent certain value classes. Sepal width is 3.5, 3, 3.2, 3.1, 3.6. Petal length is something like 1.4 to 1.3 to 1.5. Petal width is almost fixed for these 5 samples, but of course there are total 50 samples of setosa class. A minor variation in all these values is quite possible, and it is not that every flower will have exactly the same petal width all the time. So when you will look at the data, I've given you ways to extract the data and look at it. They will slightly vary, and a particular combination of all the values will indicate whether it is setosa class or versicolor or virginica class. Okay, so if it is virginica, you see that its petal length is not same as petal width of setosa. Right, this is the fourth feature, and you can always find out that this difference is quite high difference. When you go to setosa class, your flower's petal length is 1.4, 1.3, 1.5. And here it is not that less. The petal length is large, 6.0, 5.1, 5.9, etc. So we can visualize these differences. When we go to different other class, you can see that the differences are these. If you had focused on sepal width, let us come back to the previous class, sepal width. It is in the range of 3.0 to 3.6 for setosa. For virginica, 2.7 to 3. 5.3, almost similar set of value which we saw for Setusa, and for versicolor also. So sepal width is something which is not a discriminative feature, but you saw that petal width is going to be good, petal length is also going to be good. Is this sepal length which makes some difference? For versicolor it is 7. Okay, versicolar it is 7, and for virginica it is 5.8 to 7, and for Setusa it is 5.1, 4.7. It's a slightly different, but not so significant difference. Now let us look at it. Look at it more graphically. So today I'm not going to talk about any algorithm after decision tree. So it is not using KNN right now. I'm going to focus more on understanding the data first, so that when you are doing the classification, you will have sufficient idea on feature selection process as well, because feature selection is very important in classification. So today I'm not going to discuss KNN. Already we had discussed the theoretical aspect of it. So sorry, today I'm having some throat problem, so please bear with me. I may be having some cough problem. So yeah, this iris data has number of samples per class equal to 50. Total number of records is 150 for 3 classes. So it is a balanced set, that no one class is representing in large. It is the same representation of all the 3 classes in the data, which is also very important. Here, when we work with the data, this data is actually showing you the glimpses of what is there in the data set. So first you look at this code. While you had actually downloaded Anaconda, installed it on your system, and then you are using the editor for editing your code, you can write import pandas as some variable name you can give, PD. From pandas, import data frame, import matplotlib.pyplot. This is the functionality of matplotlib as plot. This is for plotting purpose. Then your data set URL you can fix up as this, okay, and then you declare in one variable called data RV. You can use pandas read CSV function to read your data from the given URL, and attribute values are prefixed with V. That is what you are seeing in the in this particular enclosure, V1 to V4. So when I'm saying in line 7 of my code, print data RV dot head, right? This one is printing us only first 5 records of that data, right? And since first 5 records are referring to only the very first class of Iris setosa, it is like this. When I'm printing data RV dot tail, it is showing me the last 5 last 5 records. With 4 such attribute values, V0, V1, V2, V3, right? These are the attribute values, and the fourth name, V4, is representing the class. So that is one thing. And then you can also use the describe functionality of this data rv.describe to store it in summary variable. And when you print summary, what it is showing you here on the screen is the total count of the records, mean per feature, standard deviation, minimum, and so many other things, right? And maximum. So this is just a kind of summary of the data, the column numbers, etc. you have, okay? Now we try to visualize this data. You can use ILOC for accessing a particular value, right? So ILOC is representing value of the data record, the 0th feature, the 0th record, sorry, 0th attribute, not the record, it is 0th attribute, and this colon is representing all records. So that means 0th attribute of all instances you are going to print here. So you are printing it in blue color and then labeling it as sepal length, right? That is what is the first feature. It is sepal length, and because I am printing legend also, it is showing me sepal length in blue. So what I have enclosed here with these boxes is only a kind of estimate of the very first 50 records, the next 50 records, and the last 50 records. You can check out the ranges of these values. The very first set is representing one particular class of Setosa flower species, another is a different one, and the third one is different, Virginica and versicolor. Definitely they have some difference, so it is a good attribute. Of course, we are not computing its entropy. We are not doing that same logic here. In this exercise, we are just trying to visualize the data and its significance, right? So visualization is also important so that you can formulate certain strategies to make use of those features which are more prominent, right? So when I'm picking up this first, that means it is the sepal width, right? So it is because the locations are starting with the 0 value. The 0th one previously was the first attribute, which is Setosa width, sorry, Setosa length, right? Sorry, sepal length it is, and then it is sepal width, then it is sepal petal length, and then petal width. So you can see that there are differences between the length of the uh, petal or width of the petal among the three classes. These three classes I am able to identify through their distribution of the sample number right now. However, it is not always true that samples are arranged so beautifully in one class after the other, right? So this is only one way of visualizing these things. Here, this parallel coordinate graph gives us a way to plot each sample, all those 150 samples corresponding to their class. You can print as per their attributes. So you can check out that this particular value, which I am marking here, the very first is representing 0th attribute, which is sepal length. Then comes another attribute, which is showing you this difference. However, it is a kind of value which is mixed that we had already seen. Sepal width is not giving us that great idea of difference, so it is not having that much discriminative ability. But here you can see the third feature, which we are calling as V2. V2 is petal length, and V3 it is petal width. So you can see if I am representing one class by green, one class by blue, and another class by red, plotting all their 50 samples per class, I'm getting 50 lines in one color representing each class 50 samples, right? So you can see here I am taking a for loop here and iterating it over a range of 150, then checking out whether it is Iris setosa class or it is Iris virginica or otherwise, and I am appropriately giving the colors, right, red, green and blue, so that I can differentiate between their relative feature values. Then I am taking up this entire row, which is picking up all the 4 features. So see, the syntax is different in different ways of accessing the data. Sometimes when you are using a particular module, it gives you a way to access 0 to third attributes. But in this ILOC method, you will have to write 0 to 4, representing this 4 as the 4 values is starting from 0. So it is actually picking up 0, 1, 2, and 3. These 4 values is starting with the 0th attribute. So for syntax, anyhow, you will have to refer to the online documentation corresponding to sklearn, corresponding to NumPy and pandas, matplotlib, because data can be accessed through any of those different ways, but their access methods will be different, right? Sometimes it may even give you a clash of the type. Because one particular module, say NumPy, would have used a different structure of the data representing the numeric value, while Pandas data frame would have taken another structure to even represent the same set of values. So while you are equating or doing some kind of manipulation, it may give you slight error. So you should be clear about the syntax of each different representation. You should understand that these all libraries are built by several different groups, and they are not belonging to the same standard Python library. But of course, it is a big help for you to learn machine learning through different other existing good libraries like sklearn. And then, of course, matplotlib gives you a way to plot these things. Okay. So here, what I'm trying to emphasize is on A2, that is this feature 0, 1, 2. The second feature, or you can call it V2 because we use the header prefix as V. It is P. It is the petal length. This is the most prominent feature which is able to discriminate between the three classes. You can see that their lines are not overlapping or superimposing each other. We are able to see most of the blue lines separate from green and red, right, in both petal length and petal width. So now I am showing you a scatter plot, which is another way to visualize the data. I've used a similar color scheme here, but I am not plotting a line for each eye. I must build a color array, which I am picking up through NumPy's append module. Okay, and then I am having these two columns. Make sure here I am taking 1:150 rows and one column, which is the second column, the second attribute. Then I'm taking the third attribute in data column 1, but it is now representing all samples, all 150 samples to get plotted as points. Because they are getting plotted here as points, the points have got some color because of the color scheme that I have defined here. So now you can see that one particular class is being represented by these two features, second and third. And now these objects, the flowers, are representing themselves as points in the two-dimensional space. This is what we had been talking about in previous classes when we were talking about the classification problem, that each object represents as a point in the n-dimensional space. Here I have taken second and the third feature. That means, what is second feature? It is petal length, and the third feature is petal width. While 0 and 1 represent sepal length and sepal width. So because of this color array, I am having the color representing 150 times, right? Based on its class, I am getting the color scheme made for all such points which are plotted according to these two columns. Is that okay? So data column 1 is representing second feature for all data, and the data column 1 is representing the third. So what is this outlier for blue color? Yeah, that is always possible. There could be one flower which is grown in different way. Its length and width are quite high, and it is mixing with another class. It is quite possible. So outliers should not affect the performance of prediction. So there are efforts and research, going on for ignoring such outliers, because K and N should not give it blue class, because another test data is falling somewhere near this outlier blue. So there are certain efforts and lot of different learning machines have evolved which take care of such kind of exceptions. Okay. So here again the similar scheme with 0 and 1. 0 and 1 represent the sepal length and sepal width. You can see that they are correlated in different way. When one particular feature is increasing, the other is decreasing. So we can say that they are negatively correlated, and of course some outliers you can also see here in red. So this you can experiment yourself and see how good it appears to visualize the data. And then I'm using this iris data for classification. It is the same process through which I am reading, but of course there is one important part which you should include here. I'm taking sklearn.linear model and importing logistic regression as model, and then I'm applying all these similar things which we did earlier. You can always check out the head and tail. While the slides are uploaded, you can check them out in the zoomed way. And some of the unhighlighted portions you can, when you type, you just uncomment them and then check out the values so that you get exact idea of what they are printing. Okay, so this is one thing, and then you have a train module which is making use of the model that you have just picked up as regression, as the logistic regression model, which is available in sklearn. Then I have this predict function which is picking up the same model, right, and then trying to predict the test features, right. Test features are obtained by rearranging some of those data, and then I'm getting accuracy. So accuracy percentage is obtained. Okay, so let us see what we are getting here. This is the complete process where I am going for 10 cross validation, right? It is a 10 cross validation. I am computing those indices which I have created from um, 1 to 150. So every such value gets reshuffled, and then I will pick up first 70% of those reshuffled values, maybe the first sample or 19th sample or 100th sample. We do not know which sample we are going to include in my training, so that has to be randomized. That is why this permutation kind of thing I have taken. So for that I have to use the NumPy, and then you will be actually picking up only the first 70% of the reshuffled indices to formulate the training data, and the remaining ones for formulating the test data. And this is the way you can pick up your data according to your IDX train and IDX test. These IDX train and test are holding those indices which were permuted and reshuffled randomly to get you the training data and test data. So feature train is holding feature data, and feature test is holding test data. So that is 70 to 30% of the total data of 150 records. And what is there in target? It is actually the fourth value, the V4. V4 is nothing but the class of the data correspondingly, right? Since we are directly picking up data RV ILOC, it is not reshuffling the class information absurdly. Whenever we are reshuffling or permuting over the records, the values along with their class names are getting reshuffled. So it is not that we are going to just distort our data by reshuffling, right? So model is trained. We are training it using the same procedure that we did earlier. And then we are predicting the classes using the prediction, then evaluating the accuracy. And then once it is done for 10 times, we are adding all these accuracies and then computing the average. It is sum underscore cross 4 divided by 10. So that will give me the average accuracy, 92.4. That is the result. And in 10 different ways, we got the accuracies as 88%, 91%, 97.7, 95.5, and so on. Why reshuffling is important? Because we want to see whether a particular training data is not affecting the performance heavily, right? So this I would expect that you um, type, run your program, and then check out the results. This is why I'm not giving you a Python code for this altogether, because this will restrict you from implementing it yourself. So look at the slides and then just type everything on your own, and maybe have your own names of variables, right? So weightage of coding is going to be hardly 10% that we are keeping for our assignments. Okay. Um, Most of the questions will be around the theory which we are discussing, but definitely the theory will be more clear if you are having a good exposure of the coding. So code is just a vehicle to understand the theory, right? So output is signifying the accuracy, the total number of correctly identified samples. Okay, and it's percentage basically. So 91.1 means 91% testing data was correctly classified. Okay, so then there is a Pearson correlation coefficient, which also gives us a way to visualize the data. Um, So assignments will not be required to do in an online lab, right? You try learning the Python details on your own. It is quite comfortable to start with, right? So not a problem. You have to learn certain things. So if there is machine learning, all the Python tutorials are available online. It is quite comfortable, and most of the programs I am giving you. So try to type in at least these and implement, and then check out certain details whenever you are stuck. Okay. So your one assignment will be in Python, and it will be using the same environment which I have suggested. Okay. So for exam, I think you need not worry right now. I will upload the details, some days before the exam. And what I want is that you need not be so highly, calculative in from the exam perspective. I think you start implementing things. Do not worry about too much its credits. When you code it, you learn several things more thoroughly, right? Otherwise, you will be leaving out certain theory portions as well if you do not visualize the data, you do not work out the programs. Fine. So we will talk about exams on the review session, and then we can clarify many things. But right now, the focus should be on learning and do whatever is suggested. So here we take these two vectors which are of equal length, and we calculate their means, mu and mv, and then we calculate their differences with their means. So delta u and delta v are calculated u1 minus mu, u2 minus mu, etc. Right? So then the correlation is defined as delta U transpose delta V divided by square root of delta U transpose delta U. This is basically going to be something like a vector and its transpose multiplication. So M is the mean. Okay. So Naveen has this doubt regarding the output. So output displays the accuracy, which is the objective of each classifier. In machine learning, we want to check out how good my classifier would be when we deploy it for actual testing. This testing is basically a validation of your algorithm. Okay. So whatever details I had given to you here as output, these are referring to the accuracies obtained in 10 different independent runs. You can check out that every time an independent reshuffling is done, an independent permutation is done, and then an independent times this feature extraction is done, and then a classification is done. So if my algorithm is behaving almost stable, say sometimes it is 88, 93, 95, but not 43, I would say my algorithm is quite good in representing its accuracies. And average accuracy is 92. Right. So any classifier is required to produce certain accuracies with which your test data would be classified. Is it okay, Naveen? So then based on the calculations which I have shown here, you will be doing this coding. This kind of color array construction is almost same which I just discussed. Data import is same. Feature vector extraction is almost similar. Only thing is 0, 1, 2, 3, etc. These are the 4 different attributes which we are trying to find the correlation among themselves. And then here I am computing the Pearson coefficient. Okay. Then I'm printing it. So then I have also used this code to check out the Pearson coefficient of correlation between every 2 pairs of attributes out of 4. So four attributes, and finding the 2 at a time, we have 6 such combinations. So Pearson coefficient is used for finding the correlation between 2 attributes. Say for example, here the Pearson coefficient is minus 0.1. It is a very small correlation, right? Sepal length and width have very small correlation. And there is scatter plot is this, right? This one has a strong correlation. When one value increases, another value decreases. So sepal length and petal length could be even more redundant information to classify. 0.87 is very high. Yeah, so I'm going to stop it in 5 minutes. Do not worry, right? So yeah, these are the only figures I'm left with. So let us talk about it. So 0.81 is the high correlation in positive direction. That means sepal length and petal width are also highly correlated. Here sepal width and petal length, they are negatively correlated, but the correlation is not as big as the previous one. It is only 0.42. Okay. So then sepal width and petal width, it is minus 0.35. Then 0.96. 0.96 is a very heavy correlation. Petal length and width, right? So this is a very heavy correlation. So once we know this data, right, then we can understand it better for feature extraction. Which features are going to be more useful and which one are not so useful. Yeah, tomorrow it is likely to be there, but in case if it is not there, then I will inform you. If it is scheduled, then it should be likely there. But yeah, if there is any information, I can send it through the portal. Fine. So I'm stopping it here. So I'll expect that you do this coding today itself and check out the results. Okay, and just have a feel of the data. So I'm stopping it here. Have a nice day. So we are likely to meet tomorrow at 2 o'clock.